We're going to talk about rational exponents. You can write a radical expression in an equivalent form using a fractional or a rational exponent instead of a radical sign. For example, if you have the square root of 36, the square root of 36 is the same thing as 36 to the 1/2 power, which of course would be 6. If you have the cube root of 64, the cube root of 64 is the same as 64 to the 1/3 power, which would be 4. And if you have the 4th root of 16, you can probably guess what that is. It's going to be 16 to the 1/4 power. And 16 to the 1/4 power is 2. I'm going to simplify each expression starting with the 216 to the 1/3 power. Just like up here, the cube root of 64 was 64 to the 1/3. Well, 216 to the 1/3 would be the cube root of 216. And the cube root of 216, of course, is 6. If you have 7 to the 1/2 times 7 to the 1/2, you could think of that a couple ways. You could think of that as you're multiplying with the same base. You could add the exponents. That'd be 7 to the 1st power, or just 7. Another way to think about that is you're taking the square root of 7 times the square root of 7. And the square root of 7 times the square root of 7 would be the square root of 49, and that is 7. We're going to simplify each expression starting with 5 to the 1/4 times 125 to the 1/4. Well, 5 to the 1/4, that's the 4th root of 5. And 125 to the 1/4, that's the 4th root of 125. So if you're taking the 4th root of 5 by the 4th root of 125, that's going to be the 4th root of 625. You could use your calculator. The 4th root of 625 is 5. You take 5 by itself 4 times, that is 625. 144 to the 1/2. If you're taking 144 to the 1/2, that's the same thing as the square root of 144. And everybody knows the square root of 144 is 12. If you have 11 to the 1/2 times 11 to the 1/2, well, 11 to the 1/2 times 11 to the 1/2, that's the same thing as the square root of 11 times the square root of 11. If you're multiplying the square root of 11 by the square root of 11, of course, that would be 11. It's the square root of 121, and that is 11. Finally, if you have 3 to the 1/4 times 27 to the 1/4, well, 3 to the 1/4, that's the 4th root of 3, and 27 to the 1/4, that's the 4th root of 27. So you're multiplying the 4th root of 3 by the 4th root of 27. That's going to be the 4th root of 81. So what number do you multiply by itself 4 times to get 81? That is going to be 3. If you have the nth root of a to the m, that is equal to a to the m over n power. When converting from radical form to exponential form, the exponent, which would be the m, goes in the numerator of that fractional exponent. The root, the n, goes in the denominator of the fractional exponent. When going the other way, when changing from exponential form to radical form, the denominator, the n, is the root, so it'd be the nth root, and the numerator, the m, becomes the new exponent. So a to the m over n equals the nth root of a to the m. I'm going to go between exponential form and radical form, starting with x to the 3/7 power. Well, if you're converting that to radical form, that 7 is the root. And that 3 in the numerator is the new exponent. So it'd simply be the 7th root of x to the 3rd. If you have x to the 1/6 power, that denominator, that 6, is the root. And that 1 in the numerator, that becomes the new exponent. So that would be the 6th root of x to the 1st. We're not going to write x to the 1st power, just x is fine. If you have the square root of y to the 5th. Now with square root, we don't write the 2 out here, but it's there. So that becomes the denominator of that fractional exponent. The 5, the exponent right now, becomes the numerator of that fractional exponent. So that would be y to the 5/2 power. Again, the root is the denominator of the fractional exponent. That exponent right now is the numerator of the fractional exponent, making that y to the 5/2 power. If you have the 5th root of b to the 3rd, the root goes in the denominator of the fractional exponent. And that 3, that exponent right now, goes in the numerator of the fractional exponent. So that would be b to the 3/5 power. We're going to again convert between exponential form and radical form, starting with that x to the negative 3.5 power. Well, first of all, that x to the negative 3.5 power as a fractional exponent, that would be x to the negative 7/2 power. Negative 3.5 is the same as negative 7/2. Now we need to make that negative exponent positive. To make a negative exponent positive, you either move it up or down, either the numerator or the denominator, opposite of where it's currently sitting. So right now, that x to the negative 7 halves, that's in the numerator, because you could write that over 1. So to make that a positive exponent, we're going to move that into the denominator, and when you do that, that becomes 1 over x to the positive 7 halves. Now you can't have a fractional exponent in the denominator like that. That's not simplified. But you can write that in radical form. That would be the square root of x to the 7th. In the denominator, that x to the 7 halves changes to the square root of x to the 7th. Now we've simplified radicals like this before. We want to get rid of the radical sign from the denominator. So to do that, you're going to make that x to the 7th into a perfect square. It's going to multiply the top and bottom by the square root of x. It's going to change that x to the 7th into x to the 8th, and then the square root of x to the 8th will be x to the 4th. So on top, it's going to be the square root of x. On the bottom, that is that square root of x to the 8th. And the square root of x to the 8th is x to the 4th. So that simplifies to be the square root of x over x to the 4th. Next, square root of negative 10. Well, that negative 10, just make sure you take the negative sign and the 10 to the 1/2 power. If you're going to write that with the fractional exponent, that would be negative 10 inside the parentheses to the 1/2 power. If you have the square root of 7x to the 3rd, notice both the 7 and the x to the 3rd are under the radical sign. So both the 7 and the x to the 3rd would be taken to the 1/2 power if you're going to exponential form on this. So you're going to put that in parentheses, put 7x to the 3rd in parentheses, and you're taking that whole thing to the 1/2 power. Converting between exponential form and radical form with this t to the negative 3/4 power. Well, t to the negative 3/4 power, that's a negative exponent. You need to make that a positive exponent. So to do that, move that into the denominator. When you move it up or down, opposite of where it's currently sitting, it's going to change that negative exponent to a positive exponent. So that t to the negative 3/4, that's in the numerator. You could write that over 1. To make that a positive exponent, move it down into the denominator, and it becomes 1 over t to the positive 3/4. Well, that t to the positive 3/4 power in radical form, going from fractional exponent to radical form, you could write that as the 4th root of t to the 3rd. So it'd be 1 over the 4th root of t to the 3rd. Now to be simplified, you have to get rid of the radical sign from the denominator. It's going to make that t to the 3rd into something that has a perfect 4th root. To do that, we're going to multiply the top and bottom by the 4th root of t. That'll make that bottom, that denominator, into the 4th root of t to the 4th, which would be t. So on top, 1 times the 4th root of t, that is the 4th root of t. And in the denominator, that is that 4th root of t to the 4th. And the 4th root of t to the 4th is t. Notice the radical sign has disappeared from the denominator. So in the numerator, it's the 4th root of t, and in the denominator, that is t. Do not cancel the t's. One is under the radical sign, and one is not. Next up, the cube root of a squared. If we're converting between exponential form and radical form, we need to take that radical form to exponential form. Well, if you have the cube root of a squared, that root becomes the denominator of the fractional exponent. That 2, the exponent right now, becomes the numerator of the fractional exponent. So that would be a to the 2/3 power. Next, the cube root of a, inside parentheses, squared. Now think about that. Do you think that's going to be the same or different than what you had on that last one? Well, the cube root of a squared, that's going to be a to the 2/3 power. That 2, that exponent, becomes the numerator of the fractional exponent. And again, that root of 3 becomes the denominator of the fractional exponent. So notice these two are the same. If you take the cube root of a squared, where that squared is under the radical sign with the a, that's the same as squaring the cube root of a. Those two results are the same. Still converting between exponential form and radical form with that z to the 1.2 power. Well, let's make that into a fractional exponent. 1.2 as a decimal changed into a fraction would be 12 over 10. So that's z to the 12/10 power. Now that 12 over 10, that will reduce to 6 over 5. So you're looking at z to the 6/5 power. I want to go from exponential form to radical form. So that z to the 6/5 power, remember that 5 becomes the root, and that 6, that numerator, becomes the exponent. So that would be the 5th root of z to the 6th. If you have the cube root of 5xy in parentheses to the 6th power. Well, the cube root of 5xy in parentheses to the 6th power, that 6 becomes the numerator of the fractional exponent, and that 3, that root, becomes the denominator of the fractional exponent, if we're changing this from radical form to exponential form. So that would be 5xy still in parentheses now to the 6/3 power. Well, 6 over 3, of course, reduces to 2. So it'd be 5xy to the 2nd power, or the quantity 5xy squared. Now inside parentheses, we're going to square each one of those inside the parentheses. So you're going to square the 5, square the x, and square the y. Well, if you square the 5, of course, that's 25. So the result would be 25x squared, y squared.